Alright, in this lesson, we're going to look some more at graphing quadratic functions, but now they're not going to be in vertex form like they were in the last lesson. So there are two ways that you can deal with this situation if the quadratic function is given in standard form f of x equals ax squared plus bx plus c. We could complete the square and put this into vertex form, but that is generally harder to do. So what we're going to do is use what's called the vertex formula. And of course, when we look at the math that's here, it looks a little intimidating, but I think you'll find it's not as bad as it looks. You remember that my vertex is an xy ordered pair, and the vertex formula gives me a way to find these two things. To get the x coordinate, we're just going to determine what b and a are and plug them into this vertex formula. And then the second part looks particularly complicated. It says y equals f of that negative b over 2a. Basically what that says is once we find x, we substitute that x value into the given function and just solve for y. So while mathematically it might look a little complicated, the actual thing that we're doing is not going to be too bad, okay? So let's look at this first problem. It says graph by using the vertex formula, and you notice it is in f of x equals, and I'm going to write it up here, ax squared plus bx plus c form. So it's in standard form. So I know the a in this case is what is in front of the squared term, which is 1. B is the number in front of the linear term, which is -4. And C is the constant, which is -2. So in order to get the vertex, all I have to do is use this and substitute it into here. Now be careful with the signs, okay? This says -b, so we want the opposite of what b is. So there's a negative in the formula. We're going to use a parenthesis and put in what b is, which is -4, over 2 times a, which is 1. So if we evaluate this, -1 times -4 is 4, over 2 times 1 is 2, gives me 2. So we know that the x coordinate of our vertex is 2. If we want the y coordinate, all we're going to be doing is plugging in that value that we just found into each x in our function. So it's x squared, so we're going to put 2 squared minus 4 times x. We'll put in 2 minus 2. Now you don't have to go overboard showing me math on these again. Of course, want to see the substitution step. And then if you enter the 2 squared minus 4 times 2 minus 2 in the calculator, that's fine. I got -6. So the y coordinate of the vertex then is -6. So all we did was use the formula to get the x coordinate. We just plugged in what b and a were, and then once we got that number, we just plugged it back in for x in our function to get the y. Okay? Now remember, when we get to talking about the shifts, this is still my h and k, just like it was before. All of these next questions are going to work the same way they did in the last lesson. My axis of symmetry, it's always an equation, and it's always x equal the x coordinate of the vertex. That's all you have to do is write that out. A, we found that up here. A is 1. And since it's positive, that means my parabola is going to open up. The absolute value of 1 is still 1. And remember, we said if the absolute value of A equals 1, that the shape is going to be the same. And then for the shifts, that's where we look at the h and k. The h is 2. Since it's positive, that means it's going to shift right. The k is negative 6. So since it's negative, that means that my parabola will shift down. Alright? So remember, when we're graphing parabolas, we always want to start with the table by putting the vertex into the middle of the chart. So we know that the vertex is 2, negative 6. Got x squared minus 4x minus 2. And once we have that x that's in the middle, just think of it as a number line. We're just going to step down 1 below 2, which is 1, and down 1 more is 0. And then on the other side of 2, if I step up 1, that's going to be 3, and up 1 more is 4. Then we just need to plug these in. I want to see this substitution. And from here, if you just enter that into the calculator, again, that's fine. You don't have to show me all the math. You can enter that whole thing at once. And I got y was negative 2. And then, of course, we're going to repeat that for each one of my x values. When I put in 1 squared minus 4 times 1 minus 2, I got negative 5. And remember, we still have the symmetry going on with this. So I'm going to expect to get a y of negative 5 for this one. So if I plug in 3, and I enter that into the calculator, I did get negative 5. And this one, I'm expecting a negative 2. And I plugged that into the calculator, and I did get negative 2. So from there, we need to graph our points. So I have 0, negative 2, 1, negative 5, 2, negative 6, 3, negative 5, and 4, negative 2. And you see my points are opposite of each other. That's how it should be because of the symmetry. And then this one, we were expecting it to open up. And it is, the lowest point is my vertex. So we're just going to connect these and draw the parabola. And you see that the graph did shift right from the origin, and it did shift down from the origin. So it did what we were expecting. All right. Let's look at one more of these. So again, I am in standard form. This is my ax squared plus bx plus c. So a is -1 this time, b is -4, and c is +4. So in order to find the vertex, I'm going to first find x. So I have negative times, in this case, b is -4, over 2 times a, which is -1. So a -1 times -4 is 4. 2 times -1 is -2. So I get the x coordinate of my vertex is -2. And then to get y, we're just going to substitute that x value back into our equation. So we have negative times x squared, and x is -2, so be careful with the signs again, -4 times x is -2 plus 4. And again, you can just use the calculator and enter that straight in. And I got a y of 8. So that should be my vertex. Then my axis of symmetry is always x equal to the x coordinate of the vertex. This time my a is -1. So since it's negative, we're going to expect it to open down. The absolute value of -1 is 1. So we expect the shape to be the same as the parent graph. These are still h and k. So since h is -2, we'll expect for the graph to shift left. And since k is +8, we will expect it to shift up. Okay? And then we're going to put our vertex in the middle. Sorry. So we got -2 and 8. Alright, so then we need to choose our other x values. So the negatives can be a little more tricky to think about. It doesn't really matter which direction you go on which side, but you can even, if you want to, draw yourself a number line. You don't have to do this, but if it helps you, you can. If I go further away from 0 from -2, it's -3 and -4. And if I go closer, it's -1 and 0. So we're going to plug these in again. Now be careful with the signs. We have a negative, and then we're putting in an x that is -4, -4 times an x that's -4 plus 4. And if you enter that into the calculator, I got 4. So we're going to repeat this. Negative x is -3 minus 4, x is -3 plus 4. And when I entered that one, I got 7. If I put in -1, for this one, I got 7, and that matches. And then finally, if we put in 0, we get 4. And again, that matches. Alright, let's graph the points. We have -4, 4. negative 3.7, negative 2.8, negative 1.7, and 0.4. And then we were expecting it to open down, so you see that my vertex is at the top. So we're going to connect our points with our parabola opening down. All right. So one thing that we use this information for a lot in math is when you think about a parabola, the vertex we've talked about is either the highest or the lowest point. So in an application problem, the highest point we can think of as a maximum and the lowest point as a minimum. So if we do just a quick visualization here, let's say this is what my parabola looks like, then my vertex, if the parabola is opening up, is the smallest or lowest point, so that is a minimum. And if the parabola opened down, the vertex is going to be the highest or largest point, so that one would be a maximum. Regardless of whether we're looking for the maximum or the minimum, we work the problem the same way because we're looking for the vertex. Okay? So if we look at the application problem we have, a local ski club sells calendars to raise money. The profit P in cents from selling X calendars is given by the function P of X equals 360X minus X squared. And if you want to, you can start right off the bat. We're not changing sides of the equation, so we can always just rewrite the order of those two terms if that makes you more comfortable. As soon as I see find how many calendars must be sold to maximize the profit, if I see the words maximize or minimize, that tells me that I want to find the vertex, because this is a quadratic function, so the maximum is going to be at the highest point, which is the vertex. So in this problem, you see that X is my number of calendars. So to find how many calendars, we're going to use that vertex formula. X equals negative b over 2a, just like we did for the parabolas in the earlier part of the lesson. So in this function, a in this case is what's in front of my x squared term, which is negative 1. B is what's in front of the linear term, is 360. And C in this case is just 0. Sorry, excuse me. I get x equals negative B, which is 360 over 2 times A. So I got negative 360 over negative 2, which is 180. So that means we need to sell 180 calendars. And then if we want the maximum profit, that's asking me to find P of X. So what it's asking for is the Y coordinate of the vertex. So just like we did before, to find Y, we're going to plug in the value we got for X. So you can put it in the original if you want. 360 times X, which is 180, minus X is 180 squared. And if you put that into the calculator, I got 32,400. So my maximum is going to be, if I sell 180 calendars, I will earn a maximum amount of $32,400.